Good day, my Facebook students. Today, with Problem Solved, we're going to do a problem using the FOIL method. Okay, going to wait a couple of minutes until I see hopefully some students live. Hello, good day to my Facebook students. Today we are going to learn about the FOIL method for those that need to review and for the students that are in pre-algebra, Algebra 1, and maybe Algebra 2. These are some of the concepts that you would need to understand in order to move forward. Okay, let's get started. All right, today we're using the FOIL method, and FOIL has a mnemonic, if I can say that, and I'm going to spell it out for you. Okay, so F stands for first. Hope you all can see this. First. Let me check, see if you can read that. Okay, first. O is outer. O-U-T-E-R, outer. I represents inner. And L represents last. Okay, let me kind of take this at an angle. So F stands for first. O stands for outer. I stands for inner, and L stands for last. Okay, we're using the FOIL method. And with the FOIL method, we have to use the distributive property. Okay, so another vocabulary is we're going to use the distributive, or distributive, however you want to say it. Distributive property. Okay, so that is one of the properties we're going to use, and then we're also going to combine like terms. So we're going to use the distributive property, and we're going to combine like terms. Okay, so here are our two vocabulary meanings, and this one up here. All right, so the first thing that we're going to do is, remember, when we have two parentheses next to each other, or I say next door to each other, or side by side, we must multiply. So I'm just going to put, it's understood in algebra, but I'm just going to put a dot here to represent multiplication, okay, for the ones that are learning this for the first time. All right, so that means we have to multiply this expression by this expression. Okay, so I'm going to use my arrows to show you the first thing that we have to do. So we have to go to F. So my first will start, so we're going to take, okay, we're going to take our variable x, and we're going to multiply to this x. Okay, so that means we're taking this x. So really this is saying x to the first power times this x to the first power. Okay? Now, because we have to understand the exponent or the power rule, we know that there's, in algebra, you're not going to pretty much see this in a book, in a textbook. You have to be taught this. There's an invisible exponent 1 there. An invisible exponent 1 there. So that's why I said x to the first power times x to the first power. That means when you're multiplying variables and the powers, you have to add the powers. So x raised to the first power times x raised to the first power equals x. 1 plus 1 equals 2. So that's going to give me x squared. Okay? This is for our first of the FOIL. Okay? So that's the first thing that we're going to do. So this is what this represents. So I'm going to write it down here so you can follow every step. So we have x times x. And remember, there's an invisible 1 there. Invisible 1. So x times x is x squared. All right? Okay. Now we have to go to our outer. For O, we have to go to the outer. So what is the outer? So this is the first. Okay. And our outer term is the outer term, first, outer, inner, last. Okay, so our outer term is here, from here to here. Okay, this is the outer. All right, maybe I'm just going to take this first right here and I'm going to put it above so it won't look confusing. So this is the first. Okay, so this is first. Our outer is from x sub x raised to the first power times positive 3. So anytime that we are multiplying, we still want to just add everything until we see the signs change. All right? So now we're going to say x sub 1, I mean not x sub 1, but x raised to the first power times 3, a positive 3. Okay? So that is equal to 3x to the first power. All right, and I'm just going to bring it down. I'm going to bring it here. So we have x times a positive 3. And I'm only putting the signs because of the teaching purposes. But in the textbook, they don't put that because it's understood in algebra. All right, so we're going to bring down our positive here. And remember, we have an invisible 1, but we don't have to put it. But I'm just showing that so you can know that. So 3 times x. Remember, in the parentheses, when they're next door to each other, that means you multiply like this. So this is going to be 3x to the first, raised to the first power. All right. So now we did first, outer. Now we're going to use a different color. We're going to do the inner. So I represents inner. And here is the inner. Okay, so that is inner. I'm just going to put it here. I-N-N-E-R. Okay, so that means we're going to take positive 2. Remember, the sign that's in front of it is married to it or joined to it. And we're going to multiply it by x raised to the first power. So I'm going to put that here. So we have a positive 2 times x to the first power. And that is going to give us 2x to the first power. Okay? So now I'm going to bring that down. Remember, I said we're just going to add. So let's put our addition. Always use addition. Okay? And we're going to put a positive 2 just for teaching purposes. Sorry, I'm using the wrong color. I want black here. So I want a positive 2 here, times x raised to the invisible first power. All right, so that's what I have here, and I'm just going to bring the arithmetic down, bring down my positive, and right here, that means if we multiply the constant by the variable, it's just 2 times whatever that is, which is 2x raised to the first power. Okay? All right. Now, we have L. L represents the last terms. So, I'm trying to do a different color. Okay. So, the last, I'm going to erase our vocabulary because I need that space. Okay? So, I'm just going to erase that because I need my space up here. All right. So, the last term would be positive 2. Take that and drop down to positive 3. So this is the last. I'll put last, L-A-S-T. That is the last term. And we're taking a positive 2 times, I'm using the dot for times, positive 3 equals, so a positive times a positive is going to give us a positive, and 2 times 3 is 6. Okay? So now let's take what I've done here, and we're just going to bring it down here to show it in our calculation. Okay? So, let's bring, so we're going to always add. Remember, always do your addition. No matter if you have a negative number, always use addition. Okay? All right. So let's bring down a positive 2 times a positive 3. All right. And then let's bring everything down so everything is just flowing downward. Positive. And we got a positive 6. So I don't have to put it because it's already understood. Now, if it was a negative number, then I would have to put it in parentheses and put, for an example, if this was a negative number, I would have to write parentheses negative 6. But we don't have a negative 6, so I could just keep the positive here, and a positive times a positive is a positive anyway. All right, so let me just erase that, and let's put 6 now. Okay? All right. If this is beneficial, please don't forget to like and share for some other students that may need this help. All right. So now we have to, first we use the distributive. This was doing the distributive. Whatever that is in the inside of the parentheses, we have to multiply within another parentheses. So we are using the distributive property. So all of this was about using the distributive property. So now at this step, we are going to combine or join together or collect like terms, or put the things that are the same together. All right, so we want to look at our first term. Remember, these are terms. They're called terms. All right, so let's look at x raised to the second power. This is an exponent. You have to know the exponent rules. So if you need to go back and review your exponent rules, Google it or look in your textbook or look at your worksheets to see if they have that information. So somehow you need to go and review your exponent rules or your power rules, okay? So in algebra, they say x squared. That means something doubled. All right, so we want to look at this term and we want to see, do we have, let me put it in a different color. Do we have another term in this expression that looks just like this, that has something, a x or something raised to the second power? Let's look at 3x raised to the first power, 2x raised to the first power, and then we just have a constant, which is 6. So we don't have anything, so we must just bring that down because we don't have anything to collect or add with or subtract with. All right, so let's just bring x squared. Let's just bring that right down here. Okay. Now, we have to look at the variables and look at the exponent again, do we have exponents that has raised to the invisible first power? So we have to look at the terms to see if there's any other terms in the expression that is the same, so we can join them or add them together or collect or combine them. So we do. We have 3x to the first power and we have 2x to the first power, so we can combine these. We can join these together. And remember, this positive is married or it is stuck to it. So that means all we have to do is add and just keep the same variable raised to the invisible 1 power. So 3 plus 2, let's bring down our positive here. So 3 plus 2 is 5. And whatever is with it, we bring it down, okay? And that's raised to the invisible 1, but we don't have to keep that there. It is understood. Any variable that doesn't have anything raised to a power or an exponent, it is going to be always 1. Okay? It's invisible. It's there, but they don't put it because it's understood in algebra. So I'm going to erase that. Okay? So let's just erase that. All right. So these two added and it became 5x. All right? So what else? Do we have anything left that has a constant? We only have one term left. So we just bring that down because that's all that we have left. So we just want to bring down what's left. Okay? So this right here is your final result. Okay? So what we did is we were able to use the FOIL method, and this is called finding the product. Product is your result after you multiply two factors or two expressions or two terms. So product is your result, okay? So what we did was finding the product for these two expressions, okay? So we were finding the product using the FOIL method. All right, so we started here and we had to use the distributive property. Just a little review. I've been talking about distributive property since my first session. Distributive property, sorry that it's at an angle, but I have to squeeze and I hope you all are listening. So we used the FOIL method: first, outer, inner, last. That's what that represents. The FOIL method. And that means you're going to find the product of this expression. And that means you have to multiply these two. Okay, and you have to know your exponent rule. You have to know what to do. So this was our first, outer, inner, and last. I just put the letters to represent the term. Okay, and then we came down here. We still use multiplication. We had to use the exponent. Understand what happens when you multiply two variables with the exponent. You must add the exponents. That's how we got x squared here. All right. And then once we follow the order, then we have to look at and we have to simplify. So what we did is we went from here to here and we had to simplify. After we did our multiplication, simplify here to here. And when we simplify all the way down to we can't do anything else. So this is the final step. Final step. Because we have x squared plus 5x plus 6. So that means we can't do anything else because do we have anything that's raised, a term that's raised to the x squared here? No, because this is x raised to the first power and you can't add unlike terms. You can't subtract unlike terms. All right, so we have 5x and we don't have another term that has an x with it. So we can't do anything. And then we have a constant, which is 6. We don't have any other constant, so we have to stop. We can't go any further. So this is our final step in using the FOIL method. Okay, so you have to remember that with the distributive property, you must multiply. So you are using multiplication. Multiply. Okay, so that's why you have to know your multiplication tables or timetables, whichever one that you learn or the terminology you use. You must understand and you must know these timetables, because a problem like this can turn into a more challenging problem. Okay? So let me step back and make sure that everything is correct. And I hope you all were able to follow step by step. And if you forget and I'm going too fast, you can always replay. Okay? Please like and share. Hopefully this is beneficial to the students. And if it's not for you, please pass it on and like and share, okay? I'm just going to check to make sure everything is correct. Okay. I think I covered all of the terms. Let me just check my notes to make sure all of the terms. So we had the first term. So remember, I talked about terms. Terms mean that this is your first term here. This is a term. This is a term. And this is a term. Okay? So when I say term, that means this is one term, the second term, the third term. Okay? Okay, I think. Oh, I also want to tell you about that we are multiplying. There's something called polynomials. Polynomials are things that look like this. It's an expression like this that you can multiply. Or it comes out, this is a polynomial. This is also a polynomial. Okay? And with polynomials, you have monomials, which is one term. Like if I had one term, it would be like a monomial. Okay? Two terms is a binomial. That means two. So I'm multiplying this binomial times this binomial. So that means I'm multiplying two expressions together, two polynomials together. Okay? So bi means two. So if I had a third one, just say if I had a third one, that would be a trinomial. Okay? But I ended up with a polynomial. Okay? All of this is polynomials. So don't let it confuse you. If you need to review that, please go Google and type in polynomials, and then go to monomials, binomials, trinomials, and take one concept at a time so you won't get confused. All right? All right, so I want to put here so you'll have it in your notes that I multiplied two binomials. Hope I can spell this. Binomials together. All right? That was in my notes that I wanted to make sure I covered them. Okay. That would be it for today because it's a lot of concepts to cover. And I want you to digest this problem, rewrite it, and try to solve it on your own. Take it step by step. And I hope you all are healthy and staying safe and figuring out what to do while we're quarantined. But if you need a review on any concepts of mathematics, from basic arithmetic, maybe all the way to statistics, hopefully as I come on, hopefully Monday through Friday, that I can provide something to help you all while you're quarantined, while you're doing your assignments, while you're in college, okay? So I'm going to say peace out, my Facebook students. Please stay healthy and safe, And please, please like and share. Okay, let me wave to some of my people that have been following me. Hope everything is clear on the board. Hello, Sadiq. Thanks for sending me, shouting out to me, challenging me to, you said, and next time show us the reverse, please. Oh, okay, so you want us to unfold foil and go backwards. Okay. Let's see. Hello to my cousin Tamika. Alrighty. And I want to shout out to whomever has sent me a donation. I really appreciate that. I wasn't expecting that. I'm not doing it for donations or anything. This is just my heart, my passion, one of my passions. And but I appreciate donations because I needed to purchase some more of these, and I had to go to Mark's because I'm running out. My dry erasers are drying out, so I needed that to keep my tools in stock. So thank you. I really appreciate that. God bless you all for that. All right, I am signing out. I appreciate you all watching, and please like and share, and take care.